There are different types of electric motors used in the automobile industry. When it comes to electric vehicles, there are 7 types of motors, with each having its own strength and weaknesses. They are: brushed DC motor, brushless DC motor, permanent magnet synchronous motor, induction motors, switched reluctance motors, synchronous reluctance motor, and axial flux ironless permanent magnet motor. Now let's see how these motors are different from one another, starting with the brushed DC motor. Brushed DC motor is one of the simplest types of DC motor. It uses brushes to transmit current to the motor winding through mechanical commutation. The armature or rotor is an electromagnet, the field magnet is a permanent magnet. This motor does not require any controller to operate or vary the speed. The advantage of these motors can be the ability to provide maximum torque at low speeds. On the other hand, the disadvantages are its bulky structure, low efficiency, heat generated by the brush, and the associated drop in efficiency. The heat is also difficult to remove as it is generated in the center of the rotor. Because of these reasons, brushed DC motors are not used in EVs anymore. Cars like Fiat Panda Elettra used a series DC motor. It is a DC motor with permanent magnets. It is called brushless because it does not have a commutator and brush arrangement. The commutation is done electronically in this motor because these motors are maintenance-free. They have traction characteristics like high starting torque, high efficiency around 95 to 98%, and are suitable for the high power density design approach. Brushless motors are the most preferred motors for electric vehicle application due to their traction characteristics. These are useful for use in small cars requiring a maximum of 60 kilowatts of power. The disadvantages are a short constant power range, decreased torque with an increase in speed, high cost because of permanent magnet. Cars like Toyota Prius used a brushless DC motor. In this motor, there are permanent magnets on the rotor. Like brushless DC motors, these motors also have traction characteristics such as high power density and high efficiency. Permanent magnet synchronous motors are available for higher power ratings. It is also expensive as compared to other motors. The advantage of this motor is that it can operate in different speed ranges without using a gear system. It is efficient, compact, suitable for in-wheel applications. It also has high torque even at very low speeds. The disadvantage is that the huge iron will lose at high speeds during in-wheel operation. Most automotive manufacturers use these motors for their hybrid and electric vehicles. For example, Chevrolet Bolt EV, Ford Focus Electric, Nissan Leaf, and BMW i3 use permanent magnet synchronous motors for propulsion. The induction motors do not have a high starting torque like DC series motors under fixed voltage and fixed frequency operation. But this characteristic can be altered by using various control techniques like vector control or field-oriented control methods. By using these control methods, the maximum torque is made available at the starting of the motor, which is suitable for traction application. Squirrel cage induction motors have a long life due to less maintenance. These motors can be designed up to an efficiency of 92 to 95%. The drawback is that it requires a complex inverter circuit and control of the motor is difficult. Induction motors are the preferred choice for performance-oriented electric vehicles due to their cheap cost. Tesla Model S is the best example to prove the high-performance capability of induction motors. Toyota RAV4 and GM EV1 also used this motor. Switched reluctance motor is a category of variable reluctance motor with double saliency. Simple and strong in construction, the rotor of this motor is a single piece of laminated steel with no windings or permanent magnets on it. This reduces the inertia of the rotor, which helps in higher accelerations. The robust nature of this motor makes it suitable for high-speed applications. It also provides high power density, which are some essential features of electric vehicles. The biggest drawback of switched reluctance motor is complexity in control and increase in switching circuit. It also has some noise issues. Synchronous reluctance motor is a synchronous electric motor, the torque of which is due to the inequality of magnetic conductivities by quadrature and direct axis of the rotor, which has no field windings or permanent magnets. Currently, this type of motor is becoming very popular as an alternative to electric as well as hybrid vehicles, due to its easy and strong construction. The main advantage of this motor mainly depends on the non-existence of rotor cage losses, by allowing a higher permanent torque than the torque of an induction motor of the same size. This motor is the most advanced motor used in EVs. It has an external rotor with no slots. The use of iron is avoided here. The stator core is also absent to reduce the weight of the machine. The air gap here is radial field type, providing better power density. A notable advantage of this machine is that the rotors can be mounted on the lateral sides of the wheels, placing the stator winding on the axle. The slotless design improves efficiency by reducing copper losses, as more space is available.